First, we look at the definition. A predicate. A predicate is a sentence that contains a finite number of variables and becomes a statement when specific values are substituted in place of the variable. So we can look at example. X squared is greater than x. So when we look at this, it's impossible to determine if this is true or false. Because we don't know the values of x. So really the truth value of this sentence expression depends on what x is. So we can pick a few numbers here and to check, plug in there, substitute the x. So let's see, if we pick integer 2, and if I replace x here with 2, then I'll get, so let's plug in here, 2 squared is greater than 2, and we can verify that is correct. So this is true. So after we plug in specific numbers, this becomes a statement because we can determine the truth value. And if we replace x with 1, and we get 1 squared is greater than 1, which is false. And we can pick 0, and 0 squared is greater than 0, that is also false. And let's pick negative 1. Negative 1 squared is greater than negative 1. So when we replace x, make sure the square is for the number negative 1. So we should put negative sign inside the parentheses. And the right side x is just negative 1. If you don't want to put parentheses on the right side, that's fine. And we can verify because negative 1 squared is positive 1 and 1 is greater than negative 1. So that makes this a true statement. Now we can pick negative 2. And let's see, negative 2 squared is greater than negative 2. We know negative 2 squared is 4, and 4 is bigger than negative 2. So that's true. Well, here I only picked the integers. So usually when we are given a sentence like this, the variable x should be given a range, what kind of numbers x can take. So in this case, in this example, let's assume x is a real number. So right here, I only picked the integers. So we should also pick some fractions and check. So let's pick 1/2 and replace x with 1/2. So this sentence will become 1/2 squared is greater than 1/2. And we know 1/2 squared is 1/4, and 1/4 is not greater than 1/2. So that makes this a false statement. And we can also pick negative 1/2 and check. Negative 1/2 squared is greater than negative 1/2, and that is because when you square of any number, you always get a positive number. That should always be greater than the negative. That also makes it true. Okay, so now because x is a real number, we are supposed to pick some irrational numbers, because we know a real number includes a real number could be a fraction or a radical number, an irrational number such as square root 2. And we can do the same thing and check. Let's see, square root 2 squared is greater than square root 2, and we get square root 2 that is equal to 2, which is greater than square root 2. So that makes it true. Well, actually, if you look for the patterns here, we noticed it seems like we can similarly pick 3 or 2.5, 1.1, 1.2, and that's when you square a number that is greater than 1, you always get a number bigger than its original. So square root of 2 actually, if you use calculator, it's about it's about 1.414. So that's when you square it, it should be greater than square root 2. So if you don't want to check square root and numbers, that's fine. Radical numbers. So let's draw our number line to try to describe what numbers will make this sentence a true statement. So I mark some of the numbers here. And let me highlight those numbers. So it seems like 1 does not work. So let's put an open circle. But we can check. If you're not sure about 1.1, you can pick 1.1, and 1.1 squared is 1.21. That is greater than 1. So 1.1 is true, 1.2, 1.3, and 2, and so on. So any number, any real number greater than 1 will have a bigger square than the number itself. But we picked 1/2. But you can pick 2/3, 3/2, any fraction between 0 and 1 and test it. When you square it, you always get a number smaller. And which, if we want to prove it, we can actually also prove that. So these numbers will not work. So we're not going to highlight them because these fractions will make the statement a false statement. Because we're looking for the values for x such that this sentence become a true statement. And next, let's look at numbers between -1 and 0. We picked the -1/2, and similarly, you can check -1/3, -2/3. That should also make it a true statement, because when you square any negative number, you always get a positive, and then it should be bigger than itself. So it looks like anything except 0 on the left side should work. Okay, so these numbers highlighted are the numbers, values for x, that will make this true statement. So in this case, we call all these numbers, we put them in a number set. So we describe those x values. So we write x first to specify what these numbers are for, and draw a vertical line to separate x from the description of x values. So x could be any number less than 0 or any number greater than 1. Well, you can use interval notation if you have learned that at your algebra class. So this is how we describe it. Or 1 to positive infinity. So this set right here, either interval notation or the set notation, we call this truth set. Apparently, the reason we call it a truth set is it's because that all the values described in the set will make this predicate a true statement. So predicate may not be called a statement before you plug in numbers, but after you plug in numbers, it becomes a statement. This here we call it domain. It's sort of like if you learn algebra or calculus class, and this is sort of like inequality with a variable, and we define what kind of x values it takes. And if we change the domain from all real numbers to positive real numbers, so for example, if x is a positive real number, well, previously we introduced the real number set notation is R. A positive real number set notation, we put a little plus sign here to represent all the positive. So when you see that, it means x is a positive real number. So in that case, the answer will change. So in this case, x actually is a real number. I'm going to use this symbol here. This means belong to. X belongs to real number set, which means x is a real number. But if we change x belongs to positive real numbers, and we won't be able to take any negative ones. So it really depends. The truth set depends on what kind of x values can take specified by the problem. Because in real life, sometimes this variable x probably means the number of books or something which cannot be negative, or the number of people. All right, so this will be the truth set if the domain for x, or in other words, you can say the values for x, the values x can take are positive ones. So that's the truth set for this predicate. So this is the predicate.